Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Now, in this second video lecture of week 11 for the course Applied Mathematics 1, we are going to learn about definite integral. So, first of all, I would like to tell you about the definite integral. The fundamental theorem of integral calculus, like you see over here, if a function f of x is continuous on the closed interval ab, then the definite integral of a function f of x in the interval in this closed interval ab is given by integration from a to b of the function f of x with respect to x is equal to, suppose the integration of this small f function is equal to f of x, which is denoted by the capital F, and this is the limit for the given integral from a to b. Now, after taking integration, putting the limit, putting the upper limit minus, then putting the lower limit. For example, we have a problem integration of 2x square plus 4x plus 1 with respect to x from 1 to 2. Integration from 1 to 2 of 2x square plus 4x plus 1 with respect to x. So, first of all, evaluate this integral and then putting the limit in the obtained result. How we can put the limit, like you see over here. First of all, put the upper limit in the obtained result and then putting the lower limit in the obtained result of the integral, and then subtract this result from this result. Subtract f of a from f of b. It's mean that first of all put the upper limit and then put the lower limit and subtract the lower limit result from the upper limit result. So, like you see over here, first of all integrate this function, integration of 2x square with respect to x plus integration of 4x and integration of 1. So, for the integration, I have already told you that adding 1 with the power and adding 1 in the denominator with the power, like you see over here, integration of x square is equal to x power 2 plus 1 divided by 2 plus 1, and this is the given limit. And now the integration of x is equal to x power 1 plus 1 divided by 1 plus 1, and this is the given limit. And the integration of 1 with respect to x is x, and this is the given limit. Now 2x cube divided by cube plus 4x square divided by 2 plus x, and now after simplification we obtain 2 by 3 x cube, a limit from 1 to 2, plus 2x square, a limit from 1 to 2, and putting the limit in this term. So putting the upper limit, putting x is equal to 2 minus putting x is equal to 1. Now in this term, putting the limit, putting the upper limit, x is equal to 2, so 2 power 3 is equal to 8, minus putting the lower limit, x is equal to 1, 1 power 3 is equal to 1. And in this term, putting x is equal to 2, so 2 power 2 is equal to 4, minus putting the lower limit, x equal to 1, 1 square is equal to 1. And now after simplification we obtain 8 minus 1 7, 7 to the 14, 14 by 3 plus 4 minus 1 3, 3 to the 6 plus 1. And now taking the LCM of these three terms, we obtain 14 plus 18 plus 3 divided by 3, which is equal to 35 by 3. So this is actually a that constant which we use in the infinite integration. So this is the constant area. This is the result of the given function which is in the constant form. Now another problem to evaluate the integration from minus 1 to 2 of the function x cube minus 2x plus 3 with respect to x. So first of all evaluate this integral and then putting the limit in the obtained result of this integration. So the integration of x cube with respect to x minus integration of 2x with respect to x plus integration of x with respect to x, integration of 3 with respect to x. So the integration of x cube with respect to x, adding 1 with the power and adding 1 with the power in the denominator. So x power 3 plus 1 divided by 3 plus 1, and this is the given limit for the integration. Now minus 2, integration of x is equal to x power 1 plus 1 divided by 1 plus 1, and integration of 1 with respect to x is equal to x. So x power 4 divided by 4 minus 2x square divided by 2 plus 3x, and this is the given limit for the integration of given function. Now putting the limit like you see over here, putting x is equal to 2, putting upper limit in this term, 2 power 4 is equal to 8 minus lower limit, and minus lower limit is minus 2, so minus 2 power 4 again 8, so we obtain 8 plus 8 in this term, and in the third term, so in the first term, like you see over here, in the first term putting x is equal to 2, so 2 power 2 is equal to 8, and putting the lower limit minus 2 power 4 again 8, so we obtain 1 over 4, 8 minus 8. And in the second term, putting x is equal to 2, so 2 power 2 is equal to 4, and putting x is equal to minus 2, minus 2 power 2 again 4, so we obtain 4 minus 4. And this result, like you see over here, 2 and 2 cancel, and in the last term putting x is equal to 2 and putting x is equal to minus 2, so upper limit minus lower limit, we obtain 2 plus 2. Now this term is equal to 0, this term also equal to 0, and 2 plus 2 is equal to 4, and 4 3 the 12. Now another problem, integration from minus under root 3 to under root 3 of t plus 1 into t square plus 4 with respect to t. So first of all, multiplied these two factors. After multiplications, we obtain t cube plus 4t plus t square plus 4. Now we evaluate the integration of t cube plus 4t plus t square plus 4 with respect to t, and after evaluating this integral, we will put the integration limit in the obtained result. So first of all, taking the integration of t cube with respect to t, adding 1 with the power and adding 1 with the power in the denominator, so we can write t power 3 plus 1 divided by 3 plus 1, and this is the given limit. And integration of t square is equal to t power 2 plus 1 divided by 2 plus 1, and similarly integration of t with respect to t is equal to t power 1 plus 1 divided by 1 plus 1, and the integration of 1 with respect to t is equal to t. Now we obtain t power 4 divided by 4, and this is the given limit, plus t power 3 divided by 3 plus 4t square divided by 2 plus 4t. Now putting the limit, when you put the limit, under root 3 is the upper limit and minus under root 3 is the lower limit. So first of all, putting the upper limit, under root 3 power 4 is equal to 9, like you see over here, under root 3 power 4 9, and putting the lower limit minus under root 3 is again 9, so 9 minus 9. And in this part, putting the upper limit, so under root 3 power 3 we obtain 3 multiplied under root 3, and putting the lower limit minus under root 3, so we obtain minus 3 into under root 3, so minus minus plus, like you see over here in this second term. Now putting the limit for the term t square, so under root 3 whole square is equal to 3, and minus under root 3 whole square, like you see over here, again we obtain 3 minus 3. And in the last term, putting under root 3 for the t, and putting minus under root 3 for the t, so under root 3 plus under root 3. Now this term cancel, and in this term we obtain under 1 over 3, and adding these two terms we obtain 6 into under root 3. Similarly this term also equal to 0, and in this term adding these two terms we obtain 4 into 2 under root 3. So 3 to the 6 we obtain 2 under root 3, and 2 for the 8 under root 3. Now adding the coefficient, so 2 plus 8 is equal to 10 under root 3. So this is the result of the given function of integration. Now another problem, to taking the integration of u power 7 divided by 2 minus 1 over u power 5 with respect to u, and the limit is given from under root 2 to 1. Integration from under root 2 to 1 of the function u power 7 divided by 2 minus 1 over u power 5 with respect to u. So first of all, taking the integration of u power 7. So the integration of u power 7, like you see over here, 1 over under root 2, 1 over and 1 over 2 will be as it is, and the integration of u power 7 is equal to u power 7 plus 1 divided by 7 plus 1. And similarly the integration of u power 5, so we can write u power 5 as u power minus 5. Actually in the given problem we have only u power 7, so the integration of u power 7 with respect to u is equal to u power 7 plus 1 divided by 7 plus 1, and this is the limit integration from under root 2 to 1. And now u power minus 5, the integration of u power minus 5 is equal to u power minus 5 plus 1 divided by minus 5 plus 1. And now we obtain u power 8 divided by 8 minus u power minus 4 divided by minus 4. Now putting the upper limit 1, so putting u is equal to 1 in this term, u power 1 power 8 is equal to 1, so 1 over 8. And now putting the lower limit under root 2, so under root 2 power 8 we obtain, like you see over here, u power putting limit 1 we obtain 1, in putting limit under root 2, so we obtain minus 16 plus, and in the second term putting u is equal to 1 we obtain 1, 1 over 4 into 1 minus putting under root 2 we obtain minus 1 over 4. Now 1 minus 16 is equal to minus 15, 1 over 8 minus into minus 15 plus 1 over 4 into 3 by 4, and this applies that minus 15 by 8 plus 3 by 16. Now taking the LCM we obtain minus 30 plus 3 divided by 16, which is equal to minus 27 by 16. Now another problem, integration from minus pi by 2 to 0 of 1 plus cos 2t divided by 2 with respect to t. So taking the integration of 1 with respect to t, 1 over 2 as it is into integration of 1 with respect to t plus 1 over 2 integration of cos 2t with respect to t. So the integration of 1 with respect to t is equal to t, and integration of cos 2t is equal to sin 2t divided by 2. And now putting the limit for this term, t is equal to 0 minus lower limit t is equal to pi by 2. Similarly for this term, multiplied 1 over 2 with 1 over 2 is equal to 1 over 4, and for this term we put the limit 0, so sin 0 is equal to 0, and sin 2 into pi by 2 you see over here, minus pi by 4 from this term 1 over 2 into minus pi by 2 minus pi by 4, and from this second term we obtain 1 over 4 into putting the upper limit sin 0 minus 2 in sin 2 into pi by 2, so we obtain minus pi by 4 plus 1 over 4 into sin 0 minus sin pi. Sin pi also equal to 0, so this term is 0, and we obtain the result is minus pi by 4. Now another problem, to integrate the function 1 minus cos 2t divided by 2 with respect to t, and the limit from the integration is minus pi by 3 to plus pi by 3. So this problem is same as the previous problem. In the previous problem we obtain 1 plus cos 2t divided by 2, and in this problem we obtain 1 minus cos 2t divided by 2. So first of all, taking the integration of 1 with respect to t is equal to t, and integration of cos 2t with respect to t is equal to sin 2t divided by 2. Now just the limit is different from the previous problem, so putting the upper limit pi by 3 minus lower limit is also minus pi by 3, so minus plus, so pi 1 over 2 into pi by 3 plus pi by 3 minus 1 over 2 multiplied 1 over 2 is equal to 1 over 4, and putting the upper limit pi by 3, so sin 2 pi by 3 minus sin into minus 2 pi by 3, minus pi by 3 is the lower limit, so this minus plus, so we obtain 1 over 2 into 2 pi divided by 3 minus 1 over 4 into sin 2 pi by 3 plus sin 2 pi by 3. So sin 2 pi by 3 actually under root 3 divided by 2 plus under root 3 divided by 2. Now pi by 3 minus 1 over 4 into 2 under root 3 divided by 2, and this implies that we obtain pi by 3 minus under root 3 divided by 4. Now to evaluate the limit from minus 4 to 4 of absolute x with respect to x. So dear students, note that absolute x is equal to plus minus x. So for minus x, the limit of the function will be equal to minus 4 to 0, and the limit for the plus x will be equal to from 0 to 4. And this implies that minus integration from minus 4 to 0, integration of x with respect to x, and the integration of plus x will be equal to from 0 to 4, integration of x with respect to x. Now integration of minus x is equal to minus x power 1 plus 1 divided by 1 plus 1, and limit from minus 4 to 0. Now plus integration of this x with respect to x is equal to x power 1 plus 1 divided by 1 plus 1, and limit from 0 to 4. So dear student, note that in this function actually absolute x is equal to plus minus x. So we divide the limit of the given limit into two parts, like you see over here. This is the property of integration, that we can put here in this corner limit from this, that is 0. This limit will be greater than from this limit and will be less than from this limit. So 0 is greater than from minus 4 and less than from 4, and 0 is between minus 4 and 4. Then this is actually the midpoint of minus 4 and 4. So minus 4 plus 4 divided by 2, this is the midpoint. So minus 4 divided by 4 divided by 2 is equal to 0. So we can write simply as the other limit is 0. So minus 4 to 0 and 0 to 4. Now putting the limit minus 4 to 0 in this part, so we obtain the limit like you see over here, minus 1 over 2 into 0 minus 16, and in the last term we put x is equal to 4. So 4 square means 16, and the lower limit is 0. So 16 minus 0. Now minus 1 over 2 into 0 minus 16 plus 1 over 2 into 0 minus 16, and this implies that 16 by 2 is equal to 8, minus minus plus, and again 16 by 2 is equal to 8, and 8 plus 8 is equal to 16. Now to evaluate the integral from 0 to pi 1 over 2 into cos x plus absolute cos x with respect to x. Now the integration of 1 over 2 cos x with respect to x we can write as it is, and in the second term we obtain absolute x. So absolute cos x again equal to plus minus cos x. So this is the integration for plus cos x, and this is the integration for minus cos ax. Now dear students, I have already told you in the previous problem that for to write this single function into integral form, into two terms integral form, this is actually the single integral, but now we write the cos x absolute and the integration of two functions. One is plus cos x and other is minus cos x. So in this case we will write the single integration in the form of two integrations. In the form of two integration, this is the lower limit 0 and this is the upper limit pi. Now in this corner I would like to highlight this point. In this corner we put a limit between 0 and pi. So this is very simple method, that here we can put a limit which will be greater than 0 and will be less than this limit, will be less than pi. So for this purpose, this is very easy how to calculate this limit. For this situation, adding these two limit and divide by 2, it's mean that find the midpoint of these two limit. 0 plus pi divided by 2, which is equal to pi by 2. So pi by 2 is a value which is greater than 0 and less than pi. Now we can write the integration of plus cos x with respect to x is from 0 to pi by 2, and the integration of r minus cos x is equal to from pi by 2 to pi. Now simple, we can put the integration of cos is equal to sine x, and similarly the integration of cos again sine x. The integration of cos is sine x, the integration of cos is sine x, and the integration of cos is again sine x. So for these three integration, just the limit is different. For the first term the limit is from 0 to pi, for the second term the limit is from 0 to pi by 2, and for the third term the limit is from pi by 2 to pi. So in the first part, putting upper limit sine pi minus putting lower limit which is equal to sine 0. Now for this term, putting the upper limit sine pi by 2 and the lower limit is sine 0 like you see over here. And similarly for the last term, putting sine pi, putting upper limit sine pi and putting the lower limit which is equal to sine pi by 2. Now after simplification, sine pi is equal to 0, so 0 minus sine 0 also equal to 0, and similarly sine pi by 2 is equal to 1, so and sine 0 is equal to 0, and sine pi again 0, and sine pi by 2 is equal to 1. So after putting the limit, we obtain 1 over 2 into 0 minus 0 plus 1 over 2 into 1 minus 0 minus 1 over 2 into 0 minus 1. So after calculation, after simplifications, we obtain 1 over 2 plus 1 over 2. Now taking the LCM of these two terms, we obtain 2 divided by 2 which is equal to 1. So in this video lecture, note that the conclusion of this video lecture that how we can evaluate the definite integral. For the definite integral, dear students, note that the limit will be given. This will be our lower limit and this will be the upper limit. So first of all, evaluate the integral of the given function and then put the limit in the obtained result. But how we can put the limit in the obtained result? Putting the upper limit in the obtained result and putting the lower limit in the obtained result, and then subtract the result of the lower limit from the result of the upper limit. Subtract the result of lower limit and subtract the result of the upper limit. First of all, putting the upper limit and then putting the lower limit, and then subtract the lower limit result, the lower, after putting the lower limit, the result which we obtain after putting the lower limit should be subtract from the result which we obtain putting the upper limit in the obtained result. So this is a very simple to first of all evaluate the given function and then put the upper limit in the obtained result, and then putting the lower result and then putting the lower limit in the obtained result, like you see over here in the definition that suppose we have a function represented by small f, and this is the function represented by the capital F. This is actually the obtained result of the given integration, and this is the given limit. So this is the obtained result of integration. Now putting the upper limit like you see over here, f of b, and putting the lower limit which is equal to a, this is f of b. So this result should be subtracted from this result. Putting the upper limit minus putting the lower limit, this will be the result of the definite integral. And now this is the end of this segment. Thank you. Allah Hafiz.